third subtopic, which is on self-inductance. So in this subtopic, you have to be able to define self-inductance and apply the formula for coil and solenoid lah. So self-induction, it is the production of EMF in a coil due to the change of current in the coil itself. Okay, so self-induction ni akan berlaku kalau ada changes, ada current punya change lah. Okay, changes in the current. Okay, so by running a changing current ataupun changing the resistor, it will create a changing magnetic flux linkage through the solenoid di sini. Okay, so bila ada change in magnetic flux, kita akan ada, we will induce an EMF lah in the solenoid itself. Okay, so induced EMF ni also known as back EMF lah, jangan confuse lah. So self-induced EMF will always be proportional to the time rate of change of the current, which is this one lah. So the formula is then equal to this one here, where L is the constant of proportionality, which is known as self-inductance. So self-inductance is simple apa? It is the ratio of self-induced EMF to the rate of change of current in the coil. So formula L ni actually N V over I lah, ataupun kalau dia ada bagi, kamu boleh guna either this equation ataupun this one. Alright, lepas tu SI unit for self-inductance is Henry, which is my father's name. So we have self-inductance for a coil and then we have for a solenoid. So these two have different formulas and it is given in your formula sheet, but I'm not sure if they mention ataupun if they label coil dengan solenoid. Itu saya tidak sure lah. Okay, so alright, that's basically the theory part. You just have to be able to apply there lah. Kamu perlu able to solve questions using this equation. So example number 7, we have an induced EMF of 5 volt. Induced EMF is 5 volt developed across a coil when the current flowing through it changes at a rate of 25 ampere per second. So this is a rate of change of current, which is 25 ampere per second. So we have to determine the self-inductance of the coil. So we know that L is equal to EMF over DI over DT. So di sini kamu just perlu substitute lah, then you will get 0.2 Henry as the answer. Okay, alright. Example number 8, we have a solenoid of 200 turns and then self-inductance of 50 millihenry carries a current of 6 ampere. Calculate the magnetic flux through the solenoid. Magnetic flux is phi. So how do we find phi? We are going to use self-inductance punya formula, which is Ln phi over I. So this is going to be Li over N lah. So berapa jawapan dia? You will then get phi to be equal to 1.5 milliweber. Okay, so that is the magnetic flux. Lepas tu dia minta magnetic flux linkage, that is uppercase phi. So that is this formula. You will get 0.3 Weber. Okay, alright, so that is example number 8. Oh, and that basically is subtopic number 3.